Hi. When you're about to choose an application framework for your next project, it's great to be able to compare different frameworks by looking at an application implemented in all of them. And there is a project called TodoMVC FX, which does exactly that. It has a reference implementation in plain JavaFX, and then it has some implementations in other frameworks. I just created an implementation of this to-do app in TornadoFX, and I wanted to show it to you and walk through the code with you. So first, let's have a look at the application itself. It's a pretty basic looking application with a header on top, a list view in the center, and a footer with some buttons and some status information. So we can add tasks using this field. So let's add one. So when we add a task, we can also edit it. And we can select this checkbox to say that it's completed. Now this items left label down here will always tell us how many items we have left to complete. And this checkbox up here will automatically be checked when all items are checked. If that's no longer the case, the check will go away. It can also be used to check all the items in the currently visible list. So let's add another in here. Let's check one of them. And now if I click this checkbox up here, they will both be checked. And if I click it one more time, it will deselect or uncomplete both of them. So let's just select this one and look at the filtering buttons down here. So by default, all the to-do items are shown. If you hit active, you will only see the active buttons, the active to-dos. And of course, if you click completed, you will only see the completed ones. Once you change status, everything will update. The item will update and the list will update automatically. So now we have two in active, and if I change status here, it's automatically moved to completed. Now in most of the samples I saw, this was actually done by swapping out the underlying lists, and that didn't feel clean to me, so that's one of the things I wanted to improve upon in my implementation. So now let's have a look at the code. So my implementation is available on this address if you want to check it out. I guess I'm going to try to submit it to this project later on. The one and only domain model object in this application is the to-do item. It has a text property and a completed property, and this is the text property and this is the completed property. It also has an ID, which is unique, and an equals and hashcode function, which is based on the ID. Now I also use an item view model, and I'll come back to how this is used in the application. Here I have an enum for the filter states. So basically these three states represents these three buttons. Let's have a look at the main view of the application. That's the window you see over here. In the top there is a header, in the center it's a to-do list, and in the bottom we have a footer. And this is implemented with the border pane. So let's have a look at the header first. We start by defining a view, and we need access to the store, and the store contains all the business logic, and we're going to have a look at that later. The next thing we do is to create a Boolean binding that will be true if all the items are done and false if not. And we need this for this checkbox state that you saw here. If I check all items, this will be checked, and if that's no longer the case, it will be unchecked. So that's why we need this. And the way we do it is to access the to-dos in the store. That's a sorted filtered list. So if you access store.todos, it will contain the currently visible items based on the filter state. So right now, if I ask to iterate over store to-dos, I would get these two. if I ask now, I will just get this, and if I ask now, I will get this instead. But the sorted filtered list has an underlying backing store of all the items unfiltered, unsorted. And that's called items inside this sorted filtered list. So what I do here is I say whenever the items change in any way, if you add or remove an item, or if one of the items are changed, I would like to recalculate this Boolean binding. And I use a collection function from Kotlin called all, which will return true if this predicate is true for all items in the list. So actually I just say, are all items completed? Then I want this Boolean to contain the true value, and if not, it will contain false. So let's look at how this view is created. So it's a VBox with a label. This to-dos label is the label up here. And it has an HBox containing the checkbox and the text field, these two. The checkbox has a class, and the reason for that is for styling, nothing else. I suspect I would need to add even more classes before I submit this, because there are some acceptance tests that will use classes and IDs to find their elements to check that they contain the correct values. Now comes the part that's really interesting, because I try to be declarative whenever I can, and TornadoFX has a lot of declarative functions that will help you to express the intent of the UI state in a very clean way. So this checkbox should also go away if there are no items in the current list, like here. So to do that, we just say that this checkbox should be visible when the store to-dos is not empty. And here you see we operate on the filtered lists. So we create a Boolean binding on the filtered list. And the view you can see, the number of items you can see, will depend on the filter state. So that's why this checkbox will disappear when we're in the active view, but it will appear in the completed and all views because we have items. And I just call the collections function is not empty to get a Boolean I can use for this visible men. Next, whenever you check this, remember we remove or set the checked state, but only on the currently visible items. So if I do like this and I go to the active state, now I will only set the items currently visible to completed when I do this. And of course they disappear, so I can find them again here. Same here. So whenever you click this checkbox, I call a store function called toggle completed, and I send in the currently selected state of this checkbox. So it will be true if it's checked and false if it's not. So the next thing here is to observe the all done Boolean and change the state of this checkbox. If the all done state we talked about earlier changes, that's what we'll check. If you see here, that's what will check and uncheck this box depending on the state of the visible items. The text field is nothing special. It's configured to have a prompt, which you can see here. And whenever you hit enter, we will call a store function called add to do with the text of the text field and then clear that text. Let's not look at the store yet, but let's have a look at the footer. The footer does almost the same thing, actually. It has an items left property, which will tell us if there are any uncompleted items. And this one has to observe the backing list, not the filtered view here, but the complete list of items, and count them to see if some are not completed. And this integer binding will always stay up to date whenever a change occurs in the backing list. This items left integer will be used to create this text of the label down here. So the footer is basically just an HBox with a style and a label, and this label has a property, and that property is a string binding. It observes this items left property, and then it writes out the value of the items left property, which will be the number of items left, and then it writes item, and then it will add an S if you have anything but one item, and then left. And this is done via an extension function on integer. and you can see the extension function here. So basically, if you call plural on any int, then it will check if it's 1, it returns an empty string, or not, it will add an s. So that's how I did this. Now for the toggle group and the toggle buttons down here, I already created an enum, and I wanted to reuse this enum instead of having some loose text strings for these buttons. So what I did was just iterate inside a toggle group. I iterated over the filter state enum values and create a new toggle button, set the name to the name of the enum, and whenever any of these are selected, I will call the filter by function of the store with the current state. So let's have a look at the to-do list. That's this piece right here. That's a list view, and it's very simple. As you can see, this list view is configured with the filtered items, the sorted filtered items from the store. That's why we inject it right here. So whenever this filtering predicate changes, the list view will be automatically updated. We make it editable, and the reason for that is that sure, you can double click to edit, but you can also leverage the editing enablement functions of the list view. So you can hit enter, or you can hit F2 to edit as well. I couldn't see that was being done in any of the other samples, and I really wanted to leverage what was already in JavaFX to make this editing work. So I use commit edit and start edit and stuff like that, and we will look at that in a second. So to create each line of UI nodes in this list, I opted to go for the cell fragment function and just reference a fragment that we will look at in a second. And this fragment is kind of the gem of this application. So TornadoFX knows how to create a fragment, a list cell fragment, whenever it's needed to show data in the list view. So let's have a look at this fragment. It's a list cell fragment, and it contains items of to-do item, the type we looked at over here. And each list cell fragment automatically gets an item property, and this item property will always contain the actual item being shown by the current line in the list view. And if you know how cells work in JavaFX, you will know that you have a function called update item, which will be called whenever a cell is supposed to represent a different value. And whenever that changes inside a list cell fragment, the item property will be updated. So the value inside will contain another item or null even. But we really want to use, of course, builders, and also be able to bind the properties of the to-do item to our label and checkbox in here. And to make that happen, I utilize a view model, because a view model will allow me to have a fixed property for each of these, the text and the completed state, that will not change even if the underlying value change, or even if it goes away. So the facade objects, the properties in the view model, will stay the same. And as you can see here, I pass in this item property. The item property is coming from the list cell fragment, and I'm passing it into my to-do item model. That's a weird thing you probably never saw before. So here it is. That's the property, and this will contain the to-do item for the current line in this list view. And what I do here is actually to configure this property as the backing item property of the item view model. This item view model always has an item property. By default, it's a simple object property. And what we could do here, instead of doing this, was actually not pass it in here, but we could make sure in an init block, we could say that the to-do item property could be bound to the item property. Sorry, let's change here. To the item property of the list cell fragment. So I could do this instead. That would be what you're used to, I guess. But if I just pass the item property of this list cell fragment into the view model, I don't even need to do that. So that's why I did it like this. So of course, when this list cell fragment is created, the item property will be null. And that means I couldn't just create my UI and bind to the to-do text and bind to the completed property inside the checkbox here. Wouldn't be possible to access the properties because they're not there yet. The item property would contain a null value. So this is now made possible by wrapping it in a view model, because now I can always bind to the facade, and whenever the item property changes, the view model facade will see those new values. So each line here is an hbox with a class and a checkbox. And this checkbox binds its value to the to-do item model's completed state. And whenever you change, when you click here, you see everything is updating. This is updating and the label is updating. And the reason it does is just because I configured the set on action to start a list view editing process and then commit it with the item currently in the list. So I kind of fake an edit just by doing this. And because the sorted filtered list containing the to-do items will refilter whenever an item is changed, this works without any additional code. So it's a very convenient way to be able to update the filtered list without having to access the to-do the filtered list's predicate and refilter it or something like that. It's all for free with this approach. That's why I did it. If we have a look at the text field, it does actually the same thing, but here it just calls commit edit. It doesn't call start edit, because this text field, as you will see in a second, is only visible whenever we're in edit mode. And how did we do that? Well, this label is the label you see here. It's only visible when we're not editing. If we enter editing mode, it goes away and it's replaced by a text field. And you will see no double click listener or anything like that that makes this label go away and the text field appear like most of the other samples, I think. What's happening here is just that the editing property of this list cell fragment, has an editing property that you can observe that will always tell you if the current line here is in editing mode or not. So this label will be removed when we're editing. And that's all I need to say. I just declare that I want to remove this label when we're editing. And the text field, it's removed when we're editing not. So when we're not editing, this text field is removed. And whenever it becomes visible, this text field, I want it to gain focus. So if I just click here, I already focused it. So if I hit F2, you see it's already focused. And that's also declaratively configured by just saying when visible, request focus. And let's see here. This label has H grow to priority always and use max size to true. That's to make it push and use all available space in between here and this delete button over here. And if we look at the delete button, it has a graphic which I extracted from the style sheet, and this will be removed whenever the parent hover property is false. So the parent of this button is the hbox, so that's basically the whole surface area of the list item, if you will. So if I'm not hovering, the button will not be visible, and also even if I'm hovering but in edit mode, it should not be visible. So that's why we OR it together with the editing property. So this creates an observable value of the state describing when to remove the button. So whenever you click this button, we call store remove to do item. Now it's time to look at the store. And it's surprisingly simple, actually. So what it has is this list I've been talking about all night, the sorted filter list of to-do items. And it starts out, blank, of course, with no elements in it. The add to do function takes a string, as we saw, and it creates a to do item object just by passing in the string. So it has a constructor that takes a text the ID will be assigned as a random UID, and the text will be assigned from this property, and the completed state is always false by default. We can sure have a quick look inside it here to see that we pass in a text string, and this is again passed to the simple string property for the text property, and the simple Boolean property for the completed state is false by default. So remove to do will just call todo's remove to do, and this is quite interesting. Both of these actually operate on the sorted filtered list, and normally that has been a read-only view of the underlying items list. So if we look inside the sorted filtered list, you will see an items, which is an observable list. And normally this is the list you had to manipulate to be able to add or remove objects. But now the sorted filtered list actually contains functions that allows it to be treated as a completely editable list. So that's why we can just add directly to the to-dos. We don't need to access the underlying items list anymore. So these are pretty simple. And then toggle completed, that's the function that was called whenever you click this button. And remember, it operates only on the elements that you can currently see. And to do that, we just say with to-dos. And now I operate in a state where this is the to-dos list. So this is the sorted filtered list. And if I iterate now, I will only see whatever is currently visible. I won't iterate over the items, the backing list. I operate over the filtered list of items. So what I do here is I'm told to set a certain state. So what I do is simply just filter, give me all the items that don't have this state. And for each of those, give it that state. So it's pretty simple. After I've done that, I need to call refilter to make the changes be visible. And lastly, we have this filter by function that was called from the footer. Remember, we iterated over the filter state values, and inside this toggle group, we created toggle buttons. When a toggle button is selected, we call the filter by function. And the filter by function will simply update the predicate inside the sorted filtered list. So if I choose completed, the predicate will tell the list to only filter the completed items. And for active, it's the opposite. And if it's not completed or active, then it will show all items. So that's it for the code walkthrough. Some of you might react to the coupling here, that almost all of the views have access to the store. If you don't like that, it would be pretty simple to change this into something where you use events. So let's for example say that we had an add to do event, and this event would have let's see, texts, and it needs to extend fx event. So if we have this event, we could listen to it. So instead of having the add to do function, we could subscribe to the add to do event. And if we get such an event, then we could do the same thing that we do here. But instead of text, we have to access it through this add event. I have to make it a value so we can access it though. So now we can get to the text up here. And to actually use this add to do event, instead of calling the controller, we need to find where we called add to do, and that was here, remember? So let's have a look in the header. Now this doesn't work anymore, and what we want to do is instead fire and an add to do event. Sorry. An add to do event with the text. Now we can remove the store reference completely. So if you like events and you want to reduce coupling, you could do that with basically all of these actually. You could even have listen to a function or an event that says give me a list of to-dos, and it could fire another event saying here are the to-dos. So you could completely ignore the store in all the views if you like that kind of approach. That's it for this walkthrough. I hope you enjoyed it, and mostly that it gave you ideas about how you can do things like this in your own applications. And also, I'm pretty sure you like the cleanliness of this approach, and how the declarative functions like remove when and when visible will make the intent of your code much more maintainable and also easier to grasp by an outsider looking at your code for the first time. Thank you for watching.